in video 3.1d, we're still solving linear equations, but in these we're going to isolate step 3, so we'll be only using multiplication and division. And then shortly we'll put it all together. Okay. Recall, we've already seen these kinds of problems where x plus 5 equals 20. So we can see that there's something in the way of getting x all by itself, and what's in the way is that 5 is being added. So what do we want to do? We want to do just the opposite to undo that. And what's the opposite of adding 5? It is subtracting 5. So we've already looked at these kinds of problems, and we would get x equals 15. Likewise, when we start with the problem x minus 5 equals 20, we look and see what's being done to keep x from being all by itself, and we see that there's a 5 being subtracted. So that tells us we want to do the opposite of that, and we're going to add 5 to both sides, and the results of that would be x equals 25. So we've already seen that kind of problem. I wanted to show those again to contrast them when we see something like 5x equals 20. So you'll notice in all of these problems, everything involves an x, a 5, and a 20. So, but what they're doing, the relationship between them differs in every case. So in 5x equals 20, there's that 5 again, and he's in the way. What is he doing with x? He is multiplying times x. So to undo that, we want to do the opposite, which is to divide by x. So I'm going to divide this side by 5 and divide this side by 5. The results are these cancel to give us a 1x, and 20 divided by 5 is 4. And in the last case, there's another x and a 5 and a 20. What is the relationship? What is happening with that 5 that we want to get rid of? It is dividing. It's x divided by 5. So what's the opposite of dividing by 5? Multiplying by 5. So that tells us that's what we want to do to both sides. And when we do that, if it helps, you can see that as 5 over 1. These cancel, and what you're left with is x equals 100. So in all of these cases, whatever it is that you want to get rid of, you see what's being done with it, and then that tells you to do the opposite. Some more simple examples. Okay, here's a negative 2x equals 8. That negative 2 is in the way, so what can we do to undo that? Well, we have to say, well, what is that negative 2 doing? It's multiplying. So we always want to do the opposite of what's being done if we want to get rid of something. So the opposite of multiplying by negative 2 is dividing by a negative 2. You'll notice that I'm dividing by the whole thing, both the 2 and the negative. And the results, it's what we wanted to happen. The negative 2 cancels with the negative 2, and we're left with x, which is what we wanted. And then divided by negative 2 is a negative 4. I want to point out something before we do another couple examples. Sometimes we'll see something that looks like this, x over 2, which means x divided by 2. Do you see that that's the same thing as 1/2 x? You can imagine we've got 1/2 times x, and then we go over 1, multiply across x over 2. So those are the same things. Likewise, a negative x over 2, you can pull out all of the numbers and make that coefficient of a negative 1/2 times x. Likewise, 3x over 2, you could, if it helps you, view that as 3/2 times x. So I just wanted to point this out. Sometimes we'll see the problems, we'll see an expression that looks like that. Sometimes we'll see an expression that looks like that. But they both mean, they mean the same thing over to the left or the right. Oh, well, there we go. There's one right there. So I think I've got to skip and go to this one for a second, and then we'll come back. Recall dividing fractions. We know that anything, I'm doing a scribble because it doesn't matter what it is, divided by 2/3, the same thing as whatever that is, times its reciprocal, which would be 3/2. So do you remember that from dividing fractions? You can change division to multiplication by flipping that number behind it. Okay, now how that's going to be relevant here. In this case, being done with the x? Well, it's being multiplied by a negative 1/2. So I go, okay, then I'm going to divide both sides by a negative 1/2. So I'm going to put this in red. Negative 1/2 divided by a negative 1/2. And I hope you're going, that is really ugly. That doesn't look fun. So this is where we will use the fact that anything divided by a fraction, and I'm just going to call it AB, is the same thing as what that is multiplied times the reciprocal. So how does that affect this problem? Let's go back, and I'm going to read the problem because that was ugly. So let's go back and see if there's a simpler way to look at this. Okay, so we decided we needed to divide by a negative 1/2, but it got kind of ugly, so I'm going, well, instead of dividing by 1/2, we could multiply by its reciprocal. So the reciprocal of a negative 1/2 is a negative 2 over 1. Okay, so does that give us what we want? Over here on the left, we could cancel those negatives, and we are left with what we want, an x. And over on the right, well, since everybody here is a whole number, we don't really need that 1 under there. So what is 8 times a negative 2? And we get a negative 16. And oops, I went a little bit too far. No, I didn't. Okay, let's see if we can use that idea again. There we go. Okay, here we've got a negative 2/3 in front of x. What is negative 2/3 doing with x? It's multiplying. So we're saying, okay, I'm just going to divide both sides by a negative 2/3. But if we don't want to make it ugly, we can recognize shortcut. Dividing by a number is the same thing as multiplying by reciprocal, and the reciprocal of negative 2/3 is a negative 3/2. So it tells us, okay, to get this, let me just remind us where we're going. We want x all by itself, and remember, x itself is the same thing as 1x. So we want to get 1 over here. So we're going to multiply by the reciprocal of a negative 2/3, which is going to be a negative 3/2, and we know if we do it on the left, we've got to do it on the right. And did we get what we wanted here? Do things cancel? We've got the 3 and the 3 cancel, the 2 and the 2 that cancels, the negative and the negative becomes positive. So we get 1x, or let's get rid of that. We've got x equals, and then over here on the right, we've got to multiply that out, and when you do, you would get a negative 12. Okay, in the next sections, we're going to be doing Hawk's problems from 3.1c, so I will see you in the next video.